is cloud computing? Cloud computing is an on-demand delivery of IT resources over the internet. Mainly the cloud computing is if you can get the IT resources. What we mean by the IT resources? IT resources mean the resources that are being used in the information technology, like servers, servers, storage, load balancers, networking resources. So if we can get these resources on demand over the internet, then it's known as cloud. So what all these cloud providers do, right? They have a massive data center on which in all over the world, and they have virtualized their physical servers and provided us a virtual service or a virtual machine or a virtual resource. In this scenario, I'm saying about virtual server because mainly we will deal with compute resources. So compute is a main topic or a main resource that is getting used in all the cloud provider. It's not only about compute, they provide the storage facility. You might have heard about Google Drives. Now all your phone data is getting backed up on your drives, right? It is automatically scheduled, and all your photos, all your emails, or even your WhatsApp chats are getting restored at a particular time. And you can retrieve that data anywhere at any time from any place in the world, right? If you are in India, you can access it from your home. If you are at office, you can access it from there. If you visit uh, outside of India, you can access those data from anywhere. So it's a kind of centralized storage that you have, and you can access that storage from anywhere. So that's how the cloud computing works. Cloud computing provide you a resource, an IT resource. IT resource, I told you, it could be a compute. By compute I mean a server. It could be a storage like a Google Drive, or it could be a load balancer that manages the load between two servers, or it could be a networking resources like VPC, routers, subnets. All these things are IT resources. And what we mean by on demand means you pay what how much you use it. So on demand basis you get that resource, you demand for that resource, you get that resource, you use that resource, you pay for it. The time period you use that resource, only for that time period you have to pay for it. So cloud computing is an on demand delivery of IT resources over the internet. On demand self service. So it's self-service. You don't have a mediator through which you have to interact to get that resource. You can log in on your GCP console, order a particular server or a particular VPC or a particular subnet. You will get that resource, use it for your project, and then you can probably delete it. You will get charged for the time being you are using it. Broad network access. So since these data centers are very large, you can access these resources over the internet. That is broad network access. You can access it from anywhere. Resource pooling. What we mean by resource pooling is, so if I give you some general idea or guidance how these Google, Amazon, or Oracle, Azure, how these data centers works, right? So they have regions and locations. So in all over the world, they have created their own data centers. Like they have a data center in Mumbai, in Hyderabad, we have a data center. Then all over the world, we have a data center, Google data center. So in these data centers, they have kept their own physical machines, physical machines as such, servers, or they have used EMC storage blocks. So those servers or the storage blocks are getting virtualized. So if I can explain you only in the compute basis, it will be easy for you to understand. So how it's being done, right? So in you have a data center. Suppose you have a data center in Hyderabad or in any location. You have a data center. In that data center you have a server. That server, on that particular server, they will provide a hypervisor. That hypervisor will virtualize that server, and you can create many servers on that physical server. So you will have one physical server. On that physical server you can create many virtual machines, and they will allocate one virtual machine to you, the configuration of the specs that you are asking for. So suppose if you need a 2 GB 2 CPU and a 4 GB RAM server, you can request that 2 GB and 4 CPU server, and you can get that server from the Google Cloud provider. So that is resource pooling. They have a broad resource, and that which they are pooling and providing you uh, the required amount that you need. Rapid elasticity. So another big advantage of using cloud is, suppose you have not used any cloud provider and you have your own data center. You have created a data center for yourself. You have brought a server, you have virtualized that server, and you're using it for yourself, not for anyone else. So you have your own physical machine. You have installed your application that on that physical machine, and it's working fine, really fine. It's more secure also. If you have your own server, it's more secure than Google, right? But the problem is, once your application get more traffic, then probably you have to increase the servers. Now you have already used the capacity of the physical server that you have brought. In order to increase the server count, you have to buy another server. And suppose your traffic goes down, then that particular server which you have brought recently is of no use, right? You have paid the money for by buying that server, but it's not getting used because your traffic has been reduced. So these all challenges that we have in configuring our own data centers are getting resolved when we use the cloud data center. So this resource rapid elasticity is as you need it. Suppose you have requested one server from GCP or from any cloud provider. You have that server, you install your application on it, you made that application live. Now your application is getting too many connections, and now you want to increase the servers. So you can ask another server, and in a minute of time you will get another server. You can configure a load balancer on top of it and install your application again on that new server. Use that load balancer to balance the traffic, and as your application or traffic goes down, you can have the counter set that once your traffic is down to below value, then delete that server. So that extra server will get deleted, and you will only pay for the timing you have used that extra server. So that is rapid elasticity. You can increase your resource very quickly. Pay as you go pricing, I have already explained you. So you will pay as much as you use it. You will not pay a penny of not of any advance fees. There is no advance fee required. You have they will provide, once you procure a server, you will get a amount that you have to pay for hour basis. So as much hours or a seconds you use it, you will get billed for it. So this is what cloud computing is. Cloud computing is on-demand delivery of IT resources over the internet. On-demand self-service, broad network access. I have explained you, this is over the internet. So this is broad network access, resource pooling. So they have multiple resources. They have virtualized that resources and provide you a particular server. Rapid elasticity, you can increase or decrease the server based on your use. Pay as you go pricing. So you will pay only for the time being you are using that server. Cloud computing. Structure as a service, platform as a service, and software as a service. What is infrastructure as a service? Infrastructure as a service is when you are using cloud provider to procure a complete infra. So if you are creating a VM for yourself, then you are procuring a infrastructure comes when you create a VM. That VM is a one infrastructure that you're procuring. So similarly, if you're procuring a VPC, subnet, routers, route tables, load balancers, these are all infrastructure as a service. You are creating your own infrastructure to deploy your application, and for in order to create that infrastructure, you procure different resources. So those resources come under the category of infrastructure as a service. Now what is platform as a service? So these cloud providers have their own applications. One best example of platform as a service is databases. So now in cloud, you don't have to, generally how it happens on the on-prem. If I give you some background, so on the on-prem, how we generally used to do it, we create one server, we request for one VMware server. On that VMware server, you generally install your SQL Server, Oracle, MySQL, Postgres, or any database. You have to install, you have to download that binaries, or you have to purchase that software from the, like if you are installing a SQL Server, you have to purchase it from Microsoft. If you are installing Oracle, you have to purchase the license from Oracle. So you buy that license, you have the binaries, you install that binary on that particular VMware server, and that VMware server is not treated as a database server. You have a database installed on it. Now this is not the trend in the cloud. In cloud, what happens is they have already installed these softwares, like we already have SQL Server, Oracle, um Postgres, MySQL. These databases are already installed. You just have to procure it. You have to select which database you want to use. Like for SQL Server, you have to select a SQL Server, and a Cloud SQL Server will get created for you on your GCP console. You can connect to that Cloud SQL Server and then start creating the database. You don't have to install any SQL Server now. You have to just manage the databases. So similar for the Oracle, you don't have to install Oracle, or you don't have to install MySQL, Postgres. So they already have installed it. You don't, and also there is one limitation that you don't have access to the physical VMs on which these softwares are getting installed. High availability is being managed by the cloud provider itself. Now they also manage the patching part. The maintenance part is also being taken care by the cloud provider. You only have to take care of your database itself. So sole responsibility of a DBA would be to manage your database, not to have any trouble on the infrastructure side. That complete infrastructure part will be managed by a cloud provider. So that is platform as a service. They provide you a platform which you can use to for your application. Like if they provide you a platform for a database, you can start creating the database and start using it. You don't have to think about anything about related to how to install or how to configure the infra. That is one example that I have mentioned here is an app engine. So app engine is a kind of service that Google provide in order to install your application directly on the software. Like we have AWS Lambda is there, you have Cloud Run is there. So these app engine is also similar feature that in which you have to just install or configure your application. The code you have to copy paste your code on the app engine and it will start running it. You don't have to manage or install any configure any binaries on the server. So that is what platform as a service is. Software as a service is a fully managed application. So in the later scenario of PaaS, platform as a service, I explained you about a database, right? So in this you have to create your own database, right? You don't have to manage the infrastructure, but you have to create the database. Suppose if you are in this database could be of any application. You can have your own application in Python and create a database in Cloud SQL and then start using that database for your application. But here it's you are creating the database. It's for your own application, right? But there are some generic application. For example, Google Drive is there. Gmail is a application itself. You don't have to do anything. You just have to create the account and start using Gmail. You have to just create an account and start using Google Drive. You don't have to install anything. You don't have to configure anything. Just start using that service itself. For example, if you have a Workday, if you have an Outlook, these Outlook is also on cloud now. You don't have to install or create a Outlook server on your on-prem and then manage it. These all things are installed. You just have to create the account and start using that application itself. So that is a software as a service. You get a software from the cloud provider and you start using it. Software as a service, platform as a service, infrastructure as a service. So this is about service models in cloud. Now regions and zones, I already told you about locations, right? So these data centers are being Google and all these cloud providers have their own data centers, and these data centers are located at a particular geographical regions. So these geographical locations are known as regions, and isolated locations within the region is known as zones. Here we have two regions, Asia South 1 and Asia South 2. Asia South 1 is Mumbai region and Asia South 2 is the Delhi region. So in Mumbai region we have three zones: Asia South 1A, Asia South 1B and Asia South 1C. So these in these zones we have the actual data centers are located in these zones, not in the region. So we have one region, Asia South 1. Suppose we have one region of Mumbai region, and not specifically in that Mumbai region itself, but near to that Mumbai region they will create different zones. So Asia South 1 will cover the complete all the three zones, all the three data centers. So you will have one Mumbai region. In that Mumbai region you have three zones: Asia South 1, Asia South B, Asia South C. Similarly for Delhi region, Asia South 2, we have three zones: Asia South 2A, Asia South 2B and Asia South 2C. And similar we have other regions, like regions are almost we have approximately uh, we have around 42 regions and 127 zones in cloud, in GCP cloud. So that's the vast network that they have, and all these regions and zones are internally connected via Google network itself. You don't have to create any connectivity for connecting from one zone to another zone. These are already cabled, and these are internal GCP network that they are, and GCP provide us the same network which they are using for themselves in order to provide their own services. The network which GCP is using, which Google is using, they provide their customer with the same reason, with the same network. So you have like Asia South 1 and 2, you have US Central 1, US East 1, US East 2, US Central 1 is IOTA, US East 1 is South Carolina, North Virginia is US East 4. Similar, we have these regions are there all over the world. Similarly, we have zones in all over the world. What's the benefit of creating this zones and regions? So benefit of creating zones and regions is, suppose you have a flood in one of the region, or you have any uh, disaster in any one of the particular region in that particular world. Suppose we have a flood in Mumbai. So if there is a flood in Mumbai, so if we have three data centers: Asia South 1A, Asia South 1B and Asia South 1C. So if there is a flood in Mumbai, it's not really important that we have a flood in Karnataka also. So they might have this AC, even though the region is known as Mumbai region, but it's not geographically, it's not restricted to only to Mumbai region. It will be cover, it will have some vast location on which they will create three data centers. So if there is a flood in Mumbai, the other data center of Asia South 1A might get affected, but 1B and 1C there might be no issues with the disaster, with the flood that has came in Mumbai region. So these zones and regions provide you a high availability fault tolerance. Similar to high availability fault tolerances, if you one of the regions, one of the zones goes down, you can get the services from other zones. Low latency. So if you have these zones and regions in different part of the world, then the latency from your core server to the end user will get reduced. Suppose you have an application developed in North Virginia, the owner of the application is sitting in North Virginia, but that application is getting used in Mumbai also, like Facebook, right? Facebook is getting used, or Gmail is getting used by everyone in this world. So if we have only one server located in America, then all the other people in the world, if they try to use that particular service, they will feel some latency due to the geographical distance that we have from India to America. So that will, for sure there will be some latency. So in order to reduce that latency, what cloud provider did is they created regions and zones, and they have deployed their services in all the regions and all the zones. So, and there will be less latency for the end user. So in order for me to use Gmail, I don't have to connect with the US application server. I can directly connect with the Mumbai. Then global infrastructure. Google data centers are energy efficient and carbon neutral. So this is what Google take a pride on it. So they what they have done, they have created their data centers on a highly renewable energy. These data center consumes a lot of energy, and lot of fresh water is getting used in order to have these, in order to cool down these servers. So what they Google has done, Google is using a renewable energy like solar energy is getting used, wind energy is getting used, water energy is getting used in order to provide electricity or power to these data centers. So Google is a most energy efficient cloud neutral data center that we have currently have in this world. Security wise, so these data centers are highly secure. Only few members of the team will have access to the data center. You particularly have a knock room from which only allocated members can enter inside the data center, and that also after doing a particular entry. Before that they cannot enter. Physical security is provided. Then we have secure boot. What other securities are provided? So Google provide secure, like their OS are hardened OS. So they don't you cannot generally access these. You have to use a cryptographic key in order to access these servers. Encrypted communication. So communication between one server or one zone to another zone is always encrypted. No middleman attack can be performed on the data that is flowing from one region or from one resource to another resource. These are highly secure and encrypted networks. Billing per second, billing for most of the services. So most of the services are getting billed on a second basis, not an hour, day or month basis. You have to bill them how much second that particular resource is getting used. You will get charged for that. So resource hierarchy, as I have already told you, organization, folder, project, and then resources are created inside the project. Each resource belong to one specific project. You cannot create a resource in two different projects. Like if you are creating a compute or a cloud SQL or a storage bucket, you have to select the project. First step is to create the project, and inside that project you have to create a resource. These resource hierarchy is basically done for you to manage your GCP account. So if you have, suppose you have an organization and you have multiple sections of in your company. You created one organization, you have an HR section, you have an IT section, you have one marketing section, and all these sections have their own resources. This is just an example. Suppose marketing people are using some AI features or reporting features. So like they are creating some reports using BigQuery, or they are using some reporting tools with AI. And then the IT people are using more like the IT resources like compute or load balancers or VPCs. So what you can do, you can have multiple projects, or actually generally what we do is, in one organization the projects are created based on the application. So you have 10 applications, all 10 applications will have its own project. So it will be easy for the billing perspective. One will have a project name as application 1 project 1. In that application 1 project 1, you can start creating all the resources which are required to run that particular application. So at end of the day, it will be easy to manage. I means manage based on the billing as well as on the security, from the security point of view. So if you want to allow one application needs access from all over the world, so you can allow access from all over the world for that particular project, and for other projects it will be restricted. And then for the billing also, the resources which are created inside that project will have a bill, and that bill will be segregated from the other projects which are created. So that's what it is. And these policies are inherited from top to bottom. If you are applying a policy on the top at the organization level or a project level or a folder level, that policy will automatically get inherited by the project or the resources which are created inside that folder organization. Identity and access management. So identity and access management defines who can do what in a GCP cloud. It's not only in GCP, it's for all the cloud providers. They have identity and access management, which is known as IAM in the general term. So what we do, there are some particular rules or policies that we have in the cloud, in the GCP console. These policies are defined in JSON format, and you have to provide the details which particular resource and what permission you are going to. Suppose you have a cloud bucket, you want to allow someone to upload the file but not delete the file, so you can only provide access to upload a file into that particular GCP bucket, but he cannot delete the file, or he cannot upload the file to any other bucket also. He can only upload the file to this bucket. So these rules are written in the JSON format, and these by rules I mean these policies, these JSON format are written in a specific for a specific resource, and then these JSON files are known as policies. I will show you these at the time of demo, so you will get more comfortable with it. And then this group of policies are known as rules. So if you have 5 policies combined under one rule, so you can create one rule and you can define multiple policies, like rule 1 or read rule. Suppose a role name is read role, and that role will have a read access. If someone gets that role, assign that role to some, if you assign that particular role to someone, that particular person will have read access on all the resources. He can see all the resources inside the project. So identity and access management defines who can do what and what on which resource. So who defines who can do what on which resource. So who is the person, or we also call it as principal. The user is known as principal. So who can do what, and member is a who, role is what permission, and resource is the resource, the actual component that you are creating in GCP, like the compute, like the GCP storage, load balancers, Vertex AI. Policy overrides allow policy. So if you have created a deny policy, suppose if you have created a policy that as I said, that this particular principal cannot delete anything from a storage bucket. So here storage bucket is a resource, that particular person is a principal, and the rule that we are defining that he cannot delete anything from that bucket is a policy, or it's a rule that we are defining. So person is a principal, resource is the GCS bucket, and then the rule that we are defining, the JSON rule or the policy that we are defining, is he cannot delete anything from the bucket. So that policy is known as role or permission that we are granting to that bucket. So suppose if you have granted a deny policy on the project level, you have created a deny policy that from this particular project no one can delete anything from the GCS bucket, and then you create a GCS bucket and provide an allow policy. You add an allow policy to a particular person that he can delete it, but since there is a deny policy at the top level on the project level, then this allow policy will not work. That's what it's saying. Deny policy overrides the allow policy. So IAM rules. This is identity and access management is roles, right? What permission that someone is getting. What is IAM role? IAM role is the same thing. Group of policies are known as IAM roles. So basically in GCP there are 3 kinds of IAM roles. One is the basic role. Basic role is owner, editor, viewer, and then billing is also there, biller role. So there are 4 basic roles in GCP. Basic roles: owner role. Owner can do everything on that particular project. If someone has a owner role assigned to him, he can do everything. Everything on that GCP. By everything I mean he can create, delete, edit, write, see the bills. Nothing is restricted for him on that particular project. So it's a owner role. Editor role, they will have, the user will have view. He can see all the resources on the GCP project, as well as he can edit the configuration of that particular resource. Then viewer role. By viewer role, he can see all the resources, but he cannot edit the role. Then there is one more role as billing role. In billing role, you can see all the resources and you can see the billing as well. With editor role and viewer role itself, you cannot see the billing information. With billing role, you can see the billing information, but with owner role, you can see everything. You can see all the resources, you can edit all the resources, and you can see the billing in details as well. Then predefined roles. So predefined roles are service specific permission. This is this is at a very broad level. Basic role is at very broad level. You have provided a owner role to a particular person, you have provided an editor role, and that editor role, he will get access to all the resources, be it compute, be it server, be it GCS bucket, or be it any resource on the GCP that you are creating. He will have editor role on the resources. Predefined role. What is predefined role? Predefined role, if you provide a specific edit role to a particular person on a particular resource, that is a predefined role. So specific service, specific permission. So if you are providing a specific permission to a specific person, like that, if a particular person can have delete permission on the storage bucket itself, he cannot delete or edit anything from the compute part. So that is a specific kind of role, right? He can only do a particular action on a particular resource, not on all the resource. So that is predefined. Custom roles, so these are least privilege access control. So how cloud providers generally work, right? It's a good practice. Recommendation is that you provide least access to everyone. You don't provide basic roles are very basic, right? If you provide an edit role, you have a critical information in your GCP, but in your GCP project you have critical servers on which production workloads are running. If some new fellow comes and he goes and edit any configuration from your GCP resources, that would be a disaster for you. So that's why a custom role, the recommendation is you provide least privilege to least privilege access control. So least privilege access control, what it means is you provide least access. The action which is required by a particular person, only that much permission should be granted to that particular principal. He should not have any more access. If my role and responsibility is to manage a compute, I should only have access on compute. If my role and responsibility is in the organization, my role and here I am in generic term, if I have joined a company and in that company my role is to manage the storage bucket, so I can only see and manage the storage bucket. I will not have access on compute, I will not have access on any other resources in the GCP bucket. Service account. So service accounts are basically used by application and services. These are not used by any users. So you create the service account in order to, for one resources to talk to connect with another resource in GCP, you have a service account. So by service account, suppose you have a compute and you are fetching some file from the internet and then storing that file on a GCS bucket. Now this compute is able to interact with the GCS bucket, right? So this compute will have its own service account. You will grant permission to this service account to access a GCS bucket. So every resource in GCP has its own service account in order to access any other resource like compute, or for example you have a application installed on a compute on a VM and you have a Cloud SQL database. Now you want your application server to connect with the Cloud SQL database. So as such compute cloud, that VM will not able to, that VM does not have any permission to access a particular Cloud SQL database, right? So we have this, but both compute and Cloud SQL will have its own service account. So what you will do in order to use that application server to connect with the database, what we have to do, we have to use the service account which is integrated with that compute and grant permission to that service account to access the database. Similarly for the buckets also, similar for the any other resource, all the resources have their own service account, and in order to use or access any other resource, we have to grant a particular permission to that service account, so so that resource can particularly use that another resource in GCP. So, and these service account do not have any passwords. These are not human interaction. No human interaction should be required. They are automatic. A compute can access a Cloud SQL. There is no human intervention required. You don't have any password. You have a authentication key. So every service account you can generate a service authentication key for your service account. should be securely managed. So you have to, since we get a key, right, so you can download that key, but that key should be managed security. It should be stored in a cyber, or you can store it in the secret bucket or secret manager in the GCP bucket in GCP. So with help of cloud identity, you can use that same user ID, same your company domain user ID can be integrated with GCP console, and you can use that ID to log in on the GCP console and start creating the resources. So in this way, actually, it becomes easy for the admin to grant you permission on the GCP console. If you leave the organization, he has to remove your ID from the domain and it will get removed from the GCP console itself. Along with this, the GCP also provided its Gmail ID can also be integrated with GCP console. When you create a Gmail ID, it will get access to a GCP console, but you have to integrate your billing account should be configured. One bank account should be configured as your billing account. You have to provide the details. So in case of some resources are getting charged, you are able to pay. I will show that in the demo itself, so you will have some more idea. So basically, cloud identity is a service through which we can manage the users and groups, and the same Active Directory and LDAP users can be integrated with GCP console, admin console for the user lifecycle, and free and premium versions are available. So this feature is available in the free as well as in the premium version. Now let's move to the interacting with GCP console. So GCP console, there are multiple ways to interact with the GCP console. One is the standard way which many of the users mainly do, that is the console and web UI console. So user interface. So what you do, you will open your web browser, you write the GCP console, and then you connect with the login with your GCP ID, then you get a GCP console opened up on your web browser. Now you can use that web browser to create any resources, manage those sources, edit those sources, whatnot. So you can use the console feature of web user interface to interact with the GCP console. Another feature which GCP provides is Cloud SDK or CLI tool. So you can download the Cloud SDK and you can install that Cloud SDK in your own system, and then you can use Cloud SDK to interact with GCP console. You can write the command gcloud commands, and those gcloud command will connect with your GCP console and start creating and editing and deleting the resources as you want. So that is another way of interacting with the GCP console with using Cloud SDK. So Cloud SDK is a kind of CLI tool. Now the third way is Cloud Shell. So now not only GCP, almost all the cloud providers provide Cloud Shell feature. So you have one Cloud Shell or a VM already created, that's a Debian VM with a light configuration. So you have one on the top of the Cloud Console. You will see an option for Cloud Shell. When you click on that Cloud Shell, half of your screen will become black and you can start interacting with the GCP console from the UI itself. You don't have to install any Cloud SDK on your system. You can use the GCP console and route the gcloud commands using the Cloud Shell. So Cloud Shell is the browser based terminal that is provided by GCP. These browser based terminals are there is one server that is installed. That server has all the latest feature of Cloud SDK and the latest version of Cloud SDK. So when you start writing the gcloud command, you can directly start creating the resources. Then API, client library, and automated bytecode. Then the fourth way is using APIs. So you can use APIs to interact with your cloud, with your GCP console. APIs are basically application interfaces that are created to you can use your code to use that API and connect with the GCP console and start creating and editing the resources. Another way is now on your phone itself you can use Android apps are there. For GCP, Android app is there, and GCP Apple Store. In Apple Store also we have an app that can be installed on your phone, and you can log in with your GCP credential and then start using the GCP console from your phone itself. It provides you the features to edit or view the resources, and you can monitor your compute and all the other resources from your mobile itself.